Okay, we're going to go ahead and start with our configurations. I didn't fill all this out, but you guys should fill all this out. The only thing that I really don't need is the material properties in here. You can go in there and do that in the section view. In fact, you can take this whole one out, or you could fill it in because you may be using this for your portfolio. You might show your spreadsheet and then show the Ipart spreadsheet and then show a bunch of the configurations of parts and how they can be different. Okay, so we've got a diameter and a length. So those are two parameters that I need to create. We're starting with the valve spring keeper pin, and it's -1. So when I go over to the spreadsheet, I wanted to show you that we have dash numbers here, -1 through 14, and then we skip to 16, and then we skip to 18. All right, now item number 23 it may not state the same thing as this, but it's the same thing. There's a long, large rod end bushing, and then there's a short one, and they're not right together. So instead of reordering this, I did it that way. Okay, so we're going to start with this one. It has a diameter of 63 thousandths and a length of 0.24. When I go in here, the first thing that Kim likes to do is project geometry. However, all I have is a circle for a rod, 63 thousandths. Now I'm going to go to home right here, and I'm going to say DIA, whatever I put in for whatever is on my spreadsheet. So if DIA is here, that's what I'm going to put in for my parameter, and I'm going to say equals. Now that one is a sketch parameter, and that messed me up. So let's do this again. Okay, so there it is, and now when I hit E for extrude, I can, of course, it's going to select inside that. I like to push my geometry away from my sketch, and now I'm going to put LE in for my parameter, equal, and then the length of that is 0.24. It's a lot easier just looking at my spreadsheet now and putting these things in. Okay, so now I have two parameters, and I have this extrusion. So I could name this extrusion, but we're all going to have that, right? We're all going to have a piece of rod extrusion. So I can leave that there. So what I'm going to do now is I'm going to create an Ipart. Go to Manage, select Create Ipart, and we're going to it brought all these in for me. It brought the diameter and the length already in. So what we're going to do is go into our part member name, and the member name is going to be valve spring keeper pin. Now the reason that we put that in there at all is when I go in to put in a part, I don't want to have to remember the part number. I want to see the common name of the part as I put it into an assembly. So valve spring keeper pin, and then I'm going to go to options right here. When I go into options, I'm going to set my value of my part number to the prefix. 0020 is a machine part, and we're going to start out with 21111, and that is our root number. Now the suffix that shows our configuration, we're going to start with it's going to have a separator of a dash, and we call them dash numbers. It's going to start with 1, and in the step 1, and it's going to have 3 digits, -001. You see how that changed that? Okay, so we're going to set this to the member part name and say OK. And yes, we're going to do this to all of them. So see how this changed this. Now I'm going to just go ahead and insert a row. My next one, look what I did. I put in the part number as my member name. So as I go to options, I'm going to set to factory name. Sorry about that. So I'm going to make this one, the second one is rocker arm fulcrum pin. It's going to be -2. The diameter of that is 125. And the overall length is 287. Okay, you can hit verify and it'll show you if anything is yellow in here, it will not make. So we go ahead and say OK. And let's see what we have now. So we have our table that we can edit. If we right click on that, we can edit it in a spreadsheet, or we can just double click on this one. I've got to create some other features on this now. So one thing that we said, if you look at the rocker arm fulcrum pin, if I pull this up, the next sheet, is that we have some flanges. We have some necks, neck down for either a hairpin or C-clip or E-clip, and then we have a chamfer that we're going to put on there. So I want to have these dimensions out here to remember what these are. So in the first pin, we're going to suppress these. In this one, we're going to allow them. And the only thing that's different between these three is the overall length of the pin. So once we get one of these, the other three is going to come in real quick. Okay? So I'm going to bring this to the side. I'm going to start with this as my sketching plane. Since this is the overall size of the flange, I'm going to put this out here, and I'm going to put in flange. Look here, if I don't put a space in there, it's going to give me a problem. Equal, what is that? Sorry. Dang it. When I go back and forth, it messes up. Thank you. So 0.187. So flange diameter equal 0.187. And it does not like it. Do you see how it stays red? So you have to have an underscore in between that for your parameters only. Okay, so we'll finish that.
Why are you going in and editing the sheet here instead of just importing the spreadsheet that already has all the information?
The question was, why don't we just import the spreadsheet? Well, we don't have all these features created yet. So we cannot put the parameters on those features. So if I put the parameters in here, then I can go in and copy the columns in my spreadsheet in, and everything can change. So I have to put the parameters in the part some way. Okay, and it doesn't know how to associate it. Very good question. So I'm going to go ahead and extrude this. Uh-oh. Dang it. I did this again. Okay, now I'm going to extrude this. Now we said this is the overall length. So I'm going to extrude this back toward the pin. So this is still the overall length. And the thickness of that flange, 0.025. Thank you so much for not happening to that. And this is going to be the flange thickness. Right? About that. So this is our parameter in an extrusion, where we can also have a parameter in a dimension inside a sketch. So I'm going to say OK on that one. The next thing that we need to do is cut that neck in here for that clip. So I'm going to select on a plane. It doesn't matter if it's this one or this one. It has to go through that axis. So I'm going to select on one of these and make a sketch. Pardon me. I'm going to project geometry. It could be an axis. It could be a plane. Bird. A plane. Okay. Now I'm going to hit Slice Graphics. That's a really nice thing. And what that does, we can only use it in sketch mode, but it cuts right through to our plane. So I'm going to project some geometry first. Where is that? The undercut of this is dimensioned from the underside of the head. So I'm going to put that in there. 214. It's going to be where it starts, and it's 18 thousandths thick. Alright. So I'm going to project geometry of the outside and the underside of this, because that's where it's dimensioned to. So I'm going to put a rectangle in here. This dimension from here to here we said was 214. Thank you. And then this dimension right here is 18 thousandths. Alright, now we need the diameter of that. That's 73 thousandths. So how do we get a diametric dimension in our drawing? Center line. So we have to have a center mark here. So I can take whatever I projected and I can actually change that to a center mark style. So I don't have to draw another one in here. The reason that I like to do that is because when we draw construction lines or center lines like this, it wants us to dimension how long they are for some reason. So I'm going to go ahead and dimension from the inside of this, from my diameter to this, and that gives me the diameter of 0.073. Now, am I going to do this way? The reason that I ask this is because this number is going to change in every one of these, and we have not created a parameter for that. But what I could do is dimension it from the bottom of the part, from the end of the part at 30 thousandths, and that would be the same for all of them. Does that make sense? So I'm going to take this one out. Sorry about that. And I'm going to dimension from here to be 30 thousandths. Now that way, this can change at all times, but it will just come from the end up. Okay, let's finish that. Or I can hit R for revolve right now and select this. It wants an axis. So you have to click on that because we can have more than one thing to revolve. And this is going to be a cut in 360 degrees. So this is called what? Flange. So I'm going to click on that and I'm going to name this. This is how we get our features to either suppress or compute. This one is going to be called neck. And now I'm going to put a chamfer on here. And I'm going to select this edge, and we said that we were going to use 15 thousandths. That's half of that distance. Okay, so I'm going to call this chamfer, not chamfer 1. Now, the other thing that you want to notice, if you have things in uppercase or lowercase, bringing in a spreadsheet into your spreadsheet for your parts, you still have to have the same case of letters. It has to be exactly the same, okay? All right, so now when I go back to my table, I'm going to edit this in the spreadsheet. So, there are some other things that we need in here though, right? So could I put in let me see. I don't want to do that yet, do I? I'm going to let Inventor do this for me. So let's go into double click on the table. We're going to go to suppression and we're going to put in the flange, the neck, and the chamfer. Now we're not going to have these in the first part, so I'm going to select this and just put in an S. And another thing that may be a difference is having a C or compute all the way in here. Okay? As opposed to my spreadsheet, which just has a C or an S. Okay, so now what I can do here, since the other ones are exactly the same, is I can insert some more lines. And you can bring this up.
You have the wrong title.
I'm sorry?
Rocker arm.
Ah, it's a roller pin. I'm sorry about that. Thank you.